On number 3 of the free response, we're given a region and with a graph there, and we're using cylindrical shells to find the volume of the solid. So let me graph this real quick. So we have square root of x minus 1 and the negative square root of x minus 1, essentially making a horizontal parabola. So those start at x coordinate 1, and we're going to 3 and stopping there. So we have this area and we're rotating it about the y-axis. So let me write out the regions. So we have bounded by square root x minus 1, we have bounded by negative square root x minus 1, and we're going from and x equals 3. And then we're rotating about the y-axis. So we have a horizontal rotation. The horizontal rotation is a clue, even if they didn't tell you, that you can use cylindrical shells here. So we need to figure out our formula. Remember that the cylindrical shells formula, we have from a to b, we have 2 pi, and we have r, integrating rh, usually dx, where r and h are some functions of x. So in this case, since we're rotating about the y-axis, the radius to any point that we're going to rotate around is just x. The only time your radius is not going to be x is if you're rotating around some vertical line that's not the y-axis. For example, if we were rotating about x equals -1, so some line over here, then our radius for each point would be the x coordinate plus 1. So you would have to have x plus 1 for r if that were the case. But in this case, we can just say r equals x. So what is our height function? The height of every cut into this region. So what is that? Well, we have an upper function and we have a lower function. So the height is just the top one minus the bottom one. And of these two, obviously the negative one is the bottom one. So we have root x minus 1 minus negative root x minus 1, which is just root x plus 1 plus root x plus 1, which is 2 times, or sorry, root x minus 1. So we just have 2 root x minus 1. So now if we plug everything in, our integral becomes, and we're going from 1 to 3 for our x. We have 2 pi, we have x, and we have 2 root x minus 1 dx. And that's the integral that we need to compute. So we could bring the 2 out front and make this 4 pi integral from 1 to 3 x root x minus 1. So this, computing the value of this definite integral will require some integration techniques that we learned at the beginning of the semester. So we need to convert this in some way so that we can actually do the integral, because remember there's no product rule or anything. Integration by parts would be a little extreme here. Instead you can think, I can't distribute that x because this x minus 1 is all raised to the 1/2 power. But if I could make it so that what's under the root is just a single term instead of 2, then I could distribute it back to the others. So this is one of those ones where you're just going to use u substitution to switch around a subtraction. So what we want is we want u to be x minus 1, which means u plus 1 equals x. And in this substitution, du is just equal to dx, so we don't have to do anything special for our substitution. So the reason we want to do that is because this is what happens. We still have the 4 pi out front. Now x becomes u plus 1. And square root of x minus 1 just becomes square root of u. Now we have the u. You can see this makes a lot more sense because now you can distribute the square root of u and everything is just a power and you can just use your standard power rule. So one more step before we actually do the antiderivative. This would be u to the 3/2 plus u to the 1/2 du. You can see now that's a very simple integral to do, and we can get the answer to this pretty quickly. So I'm going to erase the graph here, we don't need that anymore. So to compute that integral, we're going to get 4 pi times, so the antiderivative of the first term would be 2/5 u to the 5/2. We get plus 2/3 u to the 3/2 from 1 to 3. But remember that 1 to 3 is for x, so we need to plug back in. Or you could have changed the bounds from x to u, either way. So we are going to get x minus 1, because that's what u was, to the 5/2 plus 2/3 x minus 1 to the 3/2. And again, we're going from 1 to 3. Okay, so now we can just plug in 3, we can plug in 1, see what we get. You can tell right away that if you plug in 1, everything is becoming 0, so we don't even need to do that. We can just plug in 3. And when you plug in 3, these x minus 1s become 2's, and we have 2 to the 5/2 and 2 to the 3/2. Now, I think the most appropriate way to write that would be, if you have 2 to the 5/2, that's 2 times 2 times the square root of 2. So this would give us 2/5 times 4 root 2. And to the 3/2 is a whole copy times square root, so we'd have 2 square root of 2. And 4 pi is times the whole thing. So lastly, we can just distribute, or just multiply those together. So we get 4 pi times 8 root 2 over 5 plus 4 root 2 over 3. And you could go a step further and get a common denominator in that too, but I'll leave that up to you if you want to do that. That would be an acceptable answer there, though. So that was basically using the method of cylindrical shells. It's pretty simple, but remember that you're going to use that one to do horizontal rotations in terms of x.